All right, the recording is started. Thanks everyone. Once again, really appreciate you all being here for session 2 of Vipassana season 15. And throughout this season, we've been talking about components of agentic data cloud and basically agentic data cloud in action. We've been looking at data through the lens of unstructured data transformed into structured tables and relationships between them and to extract meaningful information and dependencies. Yesterday, that was our main focus. And a lot of you had some amazing questions as to why would we want to use this in our use case? Like what had we been, uh, how have we been curating the PDFs that we used in the session for the demo yesterday, the coordinate files that we used? Or is there any alternative to um, the production variant of it? Does it have to be aligned? Does it have to be curated? All great questions came up, right? So we all definitely understand. And a lot of you have also notified me offline outside the call as well that this has been really useful because you see that use case in your day-to-day, even at your workplace or things that you've been managing. It's really critical to transform unstructured data. And that is not the only point. It's also about managing files and how to do something that previously took several weeks or in cases months too in planning out the whole pipeline and productionizing it into a matter of few minutes or a matter of a couple of days in case you're just doing this CI/CD pipeline and getting everything out on track for production, right? So how is this transformation going to change the way we are building for agentic applications? So that's exactly what we've been looking at. And throughout the season, we are going to cover the use case Froyo franchise, which is going to remain the same, but it doesn't mean you can't attend session in between if you had missed a session in the past, because the application itself, each session that you're going to that we are going to cover is independent of the other session. However, the use case is continuous, but it is kept in a way that you can always pick up from the scratch. Even if you did not attend yesterday's session, you can still pick this up today because the data sourcing part, the way you're implementing it, it is also made available for today's consumption. So we get started to getting the data from the scratch. So you won't miss anything if you hadn't attended yesterday's session. Of course, you would miss the explanation, the concept, the design as to what is the this design decision that went behind going through that route and all those things, the discussion that we had. However, you will not miss the hands-on part because whatever you're going to do today is independent of that. All right. So in line with everything that we've been talking about in agentic data cloud, what we're going to do today is take the data that was converted from PDF files into structured tables into your warehouse, right? We used knowledge catalog to basically infer semantic relationships with the data that was found in all of those 400 PDFs that may or may not be related to each other, right? But in our case, we had Froyo products, which is a frozen yogurt product, and their recipe manuals and their supplier manuals, and we correlated that information using knowledge catalogs, semantic inference job, and we pushed the data to BigQuery intelligently because the inference was made intelligently through using Gemini. We didn't have to do that. It was all happening behind the scenes. All you had to do was just check that enable semantic inference checkbox in your data scan job setup. That's all we did yesterday. And the data is now residing in your data warehouse. Don't worry if it's not there. We'll do it today. Just the data creation part. Don't worry about it if you missed it. But I'm just highlighting what we did yesterday. So now we know that our warehouse contains data from all of these PDFs that are converted into structured format, semantically mapped to each other or the way they are related to each other. So in today's session, we are going to be looking at Zero-ETL data federation from BigQuery to AlloyDB. The Zero-ETL didn't have to be in the title. The reason I put it in there, I'm not against ETL. Of course, for pipelining and everything, eventually in the whole transformation process, we would need ETL. But how complicated it is or how slow or fast it is, has the latency reduced, all of that depends on the architecture you choose and the services that you choose in your application, in your entire ETL pipeline development, right? So make the wise choice. And that's exactly why I introduced the Zero-ETL part right here, because we are not going to build any sophisticated, like complicated ETLs today. We are just going to enable a few extensions and be able to federate data from BigQuery through AlloyDB without having to store it again. Now, AlloyDB is going to serve as our transactional database, which is fully compatible with Postgres. We have addressed AlloyDB in several sessions within Code Vipassana seasons in the past as well. So a lot of you are familiar with how big a fan I am of AlloyDB, but I know that most of you have called it out. Most of you have been talking about it, have used it also, and have experienced the same thing. If you ever had a chance to use it in your production applications, if that, even if you had not, you probably eventually, if you realize that this is something that your business wants or this aligns with how your application handles transactions, how your application supports latency and other things, then definitely AlloyDB is your choice because it's fast for AI operations, it's fast for transactions, it's fast for writes. It's amazing in how compatible it is with Postgres and how advanced it is in AI capabilities while being low latency and high throughput. However, in this scenario, in this session today, we are not going to look at those aspects of AlloyDB. We are going to look at the aspect of AlloyDB, which is going to allow you to federate the data warehouse, the analytics data that we already stored yesterday. So those of you who did not attend it yesterday will get a chance to store the data today in BigQuery and access that data warehouse's tables and data through AlloyDB without duplicating the data in AlloyDB again. Now, you must be wondering, what is new in this? Data federation existed in Google Cloud a few years ago, like 2 years ago or so. Yes, but it was the other way around. It's always been the case. We have talked about the data warehouse, which is BigQuery, being able to federate data, which is a lakehouse, being able to federate data from all of the transactional databases. And even across like cross-cloud databases, which is still the case. BigQuery is capable of doing that because we always want transactional data federated through our data warehouse so that your analytics gets more empowered. However, this is the reverse. We are taking analytics data from your warehouse and federating it through your transactional database because you want to empower your agentic applications. Can someone tell me why this might be a requirement? In chat, please. Why? Can you think of a reason why you want to use AlloyDB or for that matter, federate data warehouse data into your transactional system? Feel free to ping in the chat. Better accuracy to understand the data relation. For unified analysis, the word we were looking for is unified analysis. Absolutely. Accuracy, very important. I'll tell you I'll get to accuracy in a bit. Centralized, better speed, grounding, efficient visualization, multiple data sources at a place, better latency. Okay, I think I've read access data and generate report, 100% accuracy, avoid latency, performance under high load for contextual reasons. Bronze, silver, gold, and AlloyDB. Optimize storage, personalization. Personalization, great answer. So I liked all the answers. It's just that if you're thinking about reporting or analytics, perhaps not necessarily those things, but yes, you can definitely use them. But I want to highlight a few words that I read which really caught my attention. Unified analysis, yes. Contextual reasoning, yes. And there was an answer. Latency, of course, because when you're handling data warehouses data, you don't want to span out multiple connections from your agentic application. You want to have low latency and have it queried simplified from one layer. Yes. Personalization is one thing that stands out for me. The reason is, I'll get to that in a bit, but all of the things that I called out are the primary reasons. However, one thing which is very obvious on the table right here is that we are building for agents now. We are building agents using this data. So agents are no longer contain information, just what you provide. You can't, I'm not saying that you definitely need to keep your transactional and operational layer like data warehouse analytics data separate because you want to have heavy analytics, you want to have prediction, you want to have forecast and all of those things running in your analytics data. However, agents are now an essential part of business. even a day-to-day transaction. Like yesterday, I was talking about asking a user, a customer, asking the store manager a question: does Midnight Swirl contain any allergen? If we think about it, the product data, basically what the product contains, the ingredients, the recipes, and all the supplier details, all of those things are not natively transactional in nature. What is transactional in nature? It's just the name of the product, the stock, the price, the quantity, whatever it is that is essential to the bare minimum details. That's what is transactional, right? But is that enough? Because we are in the agentic era, is that enough? No. A customer is going to ask and want is going to want answers to questions that are more analytical in nature. They are not probably going to ask about, tell me which one was the highest selling. Maybe they will ask that, tell me the most popular brand, most popular product in your franchise or something like that. But that's rare. What's more common is, tell me, I don't know what I want, please recommend one thing. Now the user wants to be personalized, and the store manager is responsible for that suddenly, right? So for all these reasons, you want to merge, not merge per se, like literally merge, but you want to make sure your data from your transactional database is in alignment or is able to communicate with your analytical data, which is stored in your data warehouse, because that way your agent is empowered to answer those questions in an informed way and in a very intelligent way, so that it doesn't hallucinate, it doesn't just give out random answers by just thinking Froyo may contain dairy, so it contains dairy and stuff like that, which are hallucinated in nature. I'm not saying it's wrong, I'm just saying it's not there in the product manual, so you might as well save your business by giving them accurate information. So yes, accuracy, personalization, and unification. All of these things are the top parameters. And latency comes as a day two parameter, because a day two parameter of every business is to make sure the business is seamless and it functions in a way that there is no latency, there is no security problem, there is no observability issue, and all those things. So day two attributes are definitely important, but the top priorities are the ones that I told you about. So that is the reason we need data to be federated directly from our warehouse into our transactional data. Now, if you are wondering, um, why can't I just access it directly from BigQuery? Why doesn't the application just run a select statement directly against BigQuery? Like a lot of you answered accurately, it does affect latency if you, not because it's BigQuery, it's just because if you tempt your agent with so many different database connections and calls each time a user wants something, it's not an ideal design, right? So you can use AlloyDB's query engine to power your application's transactional and analytical workloads from within the same interface. So AlloyDB is meant for HTAP as well, which is hybrid transactional and analytical processing, analytical workloads, which is not native, which is not common for most of the relational databases out there. But AlloyDB does support HTAP, which means it's able to handle the workloads of both transactional and analytical in nature. And you can materialize or import this data on AlloyDB for faster access, like I said, without any latency, which lets you use the AI aspect of AlloyDB. While, for example, I mean, of course, BigQuery is very advanced in its AI capabilities because it's built to be your ML engine. It's built to be the base that supports your AI needs, your ML needs, and all that. But combined with AlloyDB's speed and AlloyDB's AI capabilities and indexing capabilities, you can get the data from BigQuery, and without having to store it in AlloyDB, you can empower it with everything that AlloyDB has to provide and return it to the user. So that's exactly why we will bring the transactional data, the analytical data federated through your transactional database. You're not storing it. You're just using it through another database. So that means you're only operating on it. You're not duplicating the data storage at all. Now, like this picture represents, it's just a very comical representation of this, but ultimately this is what we are doing. We are using data from, taking data from our BigQuery and federating it through transactional database through SQL queries. It's not going to be, it's referenced as a foreign table, but it's not physically stored there. Yeah, so in AlloyDB. So that's exactly what we're going to do today, right? So you won't be able to, let me clarify a few things. You will definitely be able to set up the data in BigQuery, and you will be able to submit results today from AlloyDB's overview page, but you won't be able to set up AlloyDB cluster and instance because there is no trial credits that I'm going to give to you today, because I want you to focus more on how we are, like, what are these concepts and how you can use them in your businesses and your work and your projects, rather than just chasing the steps down. However, there are some checkpoints that I want you to focus on and deliver, because we need to be sure that you're also participating, you're also hands-on, and you're also aware of what it looks like, even though you don't have to like chase down each and every step. You can just listen to the story and build the most and just touch base on the checkpoints. That's good enough. You won't be building cluster AlloyDB cluster instance and other things, because you would need a free, at least a trial building account, which you don't have. So we are going to do just the things that are available to you without a billing account. But I'm going to show you, and we have done this several times in the previous season. So setting up a AlloyDB cluster instance is a no-brainer for all of you. But I'm going to show that anyway, really quickly at my end, so you get to see all of those details. And I'll take you through the steps. But before we jump into that, I want to make sure that you're all able to follow along. So show of thumbs, you're able to get to the point, and we're all set. We're great. So glad. Thank you so much for confirmation. All right. But before we go into that, let's just set up your projects and make sure the Cloud Shell is activated and your APIs are enabled. Just that before we jump into what I'm going to show. So all of you, please follow along this step. You need to create a project or open an existing project. So what do you do? How do you do that? Let me just show that to you in a bit. Open your Google Cloud Console. I'm going to open our Google Cloud Console right here. As you can see, I'll just pin you the link to that. Sorry. Okay, here we are. It's console.cloud.google.com. This is the this is the link to Google Cloud Console. Click that link. It should open up in your default email account. Please don't let it open in default account. Choose the one. Consciously choose the email account that you want to open the console, Google Cloud Console in. In my case, I've chosen my personal Gmail account. Oh, sorry. I am in my personal Gmail account. In my case, if you see right next to the Google Cloud logo, I already have a project selected. Some of you might have an existing project. If you want to continue in that project, please feel free to stay there. But those of you who don't have an existing project, or this is the first time you're looking at Google Cloud, or you want to log in from a new account and you don't have an existing project, please see how you can create a new project right now. So you click the project picker. In the select a project dialog box on the top right corner, you have a new project button. Click that and you provide your project name and your parent resource. It is showing billing account for me because I do have active billing accounts, but you don't have to select that. You just leave it. You will not see it if you don't have a billing account. Just provision a project name and leave the parent resource by with default value and click the create button. I'm not creating one because I'm going to use my existing project. If you want to use your existing project, feel free to do that. If you want to create a project, feel free to create a project by clicking the create button. It will take about 15 seconds or less or fewer, and you should be able to see your project ID or project name listed in the project picker dropdown. So I'll give you a minute, or sorry, give you a second there so that you all catch up. Show of thumbs, created projects or use an existing project. Ankush, we are continuing the second session today, but it's okay. You can start off even if you did not attend yesterday's session, you can go on today. We are going to pump in the data again today, so no problem. All right. So if you're able to see the project picker, great. That your project in the project picker, great. Go ahead and click the Activate Cloud Shell icon, which is right next to the Gemini Cloud Assist chat icon, which is right next to the search bar. So it's the second icon from the search bar. Click that Activate Cloud Shell. It will ask you to authorize. If you haven't authorized in the recent few hours, go ahead and click authorize. And in my case, it's opening something that I already have been running here. So I'll just resume what I had. But anyway, you click authorize and you should see your Cloud Shell terminal open. Your Cloud Shell terminal should be showing your, let me show you that. It should be seeing what you're seeing in my screen right now. It should be showing your project ID right here. In my case, my project ID is agent-data-cloud. It should be showing your project ID. I'm inside a specific folder because I wanted to set up AlloyDB right before the call. So that's why you're seeing that folder. Don't worry. In your case, it should just be showing the Cloud Shell path of your root, direct workspace root directory, and you should see your project ID. If you're not seeing the project ID, open the code lab. I've sent the code lab link in the chat. I'll ping that link again right now. Yes, you can continue with the existing project. I'm pinging the code lab link right now. Please open the code lab. Go to step number 2, which is before you begin. If you scroll down to point number 7, there is a gcloud config set project and followed by your project ID. You have to specify your project ID there. So copy the gcloud config set project, come back to your Cloud Shell terminal and paste that command. And in the end, just add your project name. In my case, sorry, project ID, not name. Where will you find the project ID? If you click the project picker drop down to the right hand side of your project name, you'll see type followed by ID. So copy the project ID from there and paste it right here, or you can just type your project ID if you already know it. And hit enter. It will now show your project ID in the prompt of your Cloud Shell terminal, and you should be all set. So with that, let's just continue. You won't be, you'll only have to do one small thing, which you see in point number 8 in the Cloud Shell terminal, in the code lab, which is gcloud services enable alloydb.googleapis.com. We are enabling AlloyDB API. Now, you are not going to create cluster or instance, but go ahead and enable the API because this has something to do with the result submission. I'll tell you in a bit, but just copy this command. Go to code lab, step number 2, copy the gcloud services enable command and come back to your Cloud Shell terminal, paste this command and hit enter. This should enable your AlloyDB API. That's it. It won't do anything else. It will just enable the API. You will not see any result. It will just quietly prompt you back to the it ready for the next command. So that's pretty much it. So in this step, what we've done is we have created a Google Cloud project, activated Cloud Shell, and enabled AlloyDB API, because before starting any service in Google Cloud, you would want to enable that API so that you tell the project that you're going to use the service in this particular project. So that's pretty much it. All right. So now that we have AlloyDB, let's get to step 3 of the code lab, which is again a quick recap of what we did in part 1. But don't just skip this part. Folks who already did this yesterday will not have to repeat it unless you deleted the BigQuery table. Folks who are just attending this session, it's very easy to just set up the data in BigQuery directly. Now, this is not the only thing we did yesterday. We saw how knowledge catalog extracted and pushed this data into BigQuery. However, all the participants were only able to create the table, the dataset table, and the data directly into BigQuery yesterday. So that's what we're going to do today as well, before I move on to the the 4th step of the code lab, right? So let's all go ahead and do the step 3, which is inserting data into BigQuery. Why are we doing this? Because some of you are probably attending session 2 and missed session 1, and some of you would have deleted the table. So if you already have this data set and table and data ready to go, just listen in, don't do anything. Those folks that need this table and data to proceed with today's session, please go ahead and do this step. All right. So what we're going to do right here is we are going to create a BigQuery data set called froyo_data in US Central 1 location, that is region. Let's go ahead and copy this command from code lab, step number 3. Go back to your Cloud Shell terminal. Let me clear this up. All right. And paste this. Because this is a Cloud Shell command to directly create BigQuery's dataset. You can also do this from BigQuery's console, but since I have made the commands available, you can just directly hit enter. This will create a data set named froyo underscore data. I'm getting an error because I already have this data set. So I'm going to create another one. But you just copy paste what is there in the code lab. If you already have the data set, don't do it again. Just listen. We'll quickly finish this in a few minutes. All right. What is the next step? We are going to download the, how many files are there? 8 CSV files from the GitHub repository to your current working directory. Why are we doing this? So that we can use the CSV to create table and data in BigQuery from command shell itself. Why can't we just take the data and go through knowledge catalog? You can, but you don't have billing account, and we are not going to wait for the job to complete right now. So I just made the CSVs available. So all of you can download the CSV into your working directory and push the data directly to BigQuery. In your production workflow or in your development environment, you wouldn't be doing this. You will ideally be taking the full route. But right now I made the data available for you. So let's go ahead and copy these commands one by one and run this from your Cloud Shell terminal so that so that you're able to create this table, these 8 tables, and insert the data. Right. So there we go. It has created CSV number 1. Don't do this if you already have the data in your BigQuery. This is only for folks who are new. Right. Copy the 3rd file and it works. Copy the 4th. Do the same thing again. Works. 5th file. Saved. 6. Wait. Is it 5 missing? No. I apologize. Last one. Why do I feel like I missed copying one? All right. Anyway, I have all the files. There are 8 files listed here. You should have copied all the 8 files. Allergen.csv consists of .csv, contains allergen.csv, Froyo data materialize.csv, ingredient.csv, product.csv, supplied by.csv, and supplier.csv. I think I missed product.csv if I'm not wrong. Yeah, that's what it is. All right. So now we have downloaded the CSV files to your current working directory directly from the GitHub repo. Now what I'm going to do is I'm going to run these 8 BQ load commands to load these CSV files as tables and data into BigQuery. So so once you complete these 8 commands, you should be able to see these tables and data in BigQuery. All right. So let's go ahead and run these. You'll see errors in my screen because I already, no, I'll actually change the data set name. Going to pause errors. Right. Oh. Upload complete. And don't delete this data, okay? We will continue to use this data for the rest of the sessions as well. So if you're planning to attend the rest of the sessions for the season, don't delete the BigQuery data. It's not going to cost you anything. So just leave it there. You haven't put in a billing account anyway, so don't worry. Just leave it there. Let this data stay. Um, I'm copying the second BQ load command. Third, so it's down there. It's the third one. it should say current status is down. Only then you can move on. Ports. Okay. Okay. 6, 7, and just one more, and I'll be done. Sorry for the wait. Last one. All right. So now we have all the 8 tables along with the data in the newly created data set. So how would you test that? Go to, so you can select this Cloud Shell terminal down, and in the search bar, type BigQuery. For folks who are already in BigQuery, just hold on for 1 minute more. For folks who already have the data, just wait. And for folks who are just creating this data, go to BigQuery. The moment you type BigQuery in search bar, you'll see BigQuery product in the top results. Click that. You will land here in BigQuery console. You will see the navigation menu, navigation pane on the leftmost part of the console. And then you will expand this middle pane, which is the Explorer pane. This is where you will see your project ID. Expand your project ID. You will see the data sets listed right there. As you can see, my newly created data set is here, and all the 8 tables are showing. Great. So this is how we inserted data yesterday as well, the participants. I showed how you can do the same thing from knowledge catalog without having to go through the CSV route. However, the participants were able to upload CSV directly and get the tables created in BigQuery. Show of thumbs, how many of you completed? Those who are new and those who already have the BigQuery tables. Awesome. Perfect. Let's move on. So now that we have our BigQuery data, what are we going to do? We just discussed it a few minutes ago, right? We are going to take this data and we'll go to AlloyDB, and we are going to be querying AlloyDB to fetch your BigQuery data directly without having to store it again in AlloyDB. Like we said, why are we doing this? To empower your agents with both transactional and analytical information. You must be wondering, I don't have any transactional data yet in AlloyDB. Yet. Yes, you don't have transactional data yet in AlloyDB, but in Monday's session, we are going to be building an agentic application which will connect the dots, all of these dots together. So you'll understand why we brought in this, why we first of all created data, like use knowledge catalog to convert PDFs to data warehouse data, and why did we federate that through AlloyDB, and how this unified data is talking to your agent, or how your agent is talking to this unified data. All of this you will be able to understand on Monday. But for now, just know that from AlloyDB, you'll be accessing all of these tables through queries, and you'll be able to query the tables in BigQuery from AlloyDB. That's exactly what we're going to do, but it takes a few steps. So moving on to next step, setting up AlloyDB cluster, instance, and network. So at this point, I want to recall the quick AlloyDB setup code lab, which we did in season 13, the first season this year, 2 seasons ago. um, where this was the session one. We use this code lab to set up AlloyDB. I'm not going to ask you to go and recall or open the cluster instance from that time. I'm just recollecting the fact that we've already done this. So I'm just going to show you the code lab. This is that code lab. It is linked in the present code lab as well. How easy it is for you to click this button and instantly, or you can choose, if you don't want to click that button in a production workspace or in your staging environment, you can just use the git clone approach as well, alternative approach. You can clone the repository and get your easy AlloyDB setup repo created in your local or working directory. And then you can run an application by running sh run.sh command. And this is the application, if you remember, this is the application we ran where you had to just provide your project ID. You have to choose the region that you want to fetch your set up your cluster and instance in. You have to provide, or by default, it comes with a cluster name and instance. If you want to change it, you can change it. You will provision a password and you click deploy. And it will take about 10 to 15 minutes and it will create your cluster and instance. I just ran this 15 minutes before the session started and I got my AlloyDB cluster and instance created, as you can see right here. If you see right here, I have my AlloyDB cluster and AlloyDB instance created just now. All right. I'm not going to go through all these steps again because I gave you the code lab. We've already done this. And if you don't just go through the code lab, it's just a one-click deploy of AlloyDB cluster and instance. By the end of it, you will get your credentials. You can see the credentials. Okay, it's timed out. Remember, I just did a control C on the terminal. So this app is not presently running. But if you go and run this sh run.sh command, the app will be running and you'll be able to see the response here as well. Right now, the app is not running. However, my job completed successfully. As you can see, deployment complete. In the console, it showed to me all the details of my cluster and instance. If I click this view details, it would have given me the password, the IP address and everything. But since my session is not running, it's not showing. Anyway, that was that. That was the whole point of setting up cluster and instance. I'm going to close that code lab. I already have my cluster and instance selected, created, sorry. So how do you all go to AlloyDB and look at what you're able to see? Again, go to click Google Cloud logo and come back and land on your Google Cloud console or open a new tab and go to Google Cloud console. Make sure your project, your active project name is listing here in the project picker. In the search bar, type AlloyDB. Sorry. And in the products and pages, this is the first one that you see, AlloyDB for PostgreSQL. Click that. This is what AlloyDB console looks like. In my case, since I just created a cluster and instance, you're seeing a list here with one entry, one cluster and one instance. In your case, you wouldn't see anything. You'll probably be seeing enable billing or something like that. But this is an important step for you all. This is what you're going to submit for your result. Whatever you're seeing in the AlloyDB overview page, this clusters page, along with your project picker, project ID showing. So this part is what you need to submit. What you're seeing in my, I'll just show it to you. This is what you need to submit for your result. You should be able to see your project ID. You should be able to see whatever it is that you're seeing in your AlloyDB console. It's also there in the code lab in step number 6. If you see the first step in the code lab, sorry, the first point in the step 6 of the code lab is what you will be submitting as a result for this session today. However, in the screenshot in step number 6, it does not show my project ID. You should be showing your project ID in the result submission process and ping it right away so that you all can go ahead and submit the result right away while you're listening into the session. Result validation. Oh, sorry, that's it's not good.gl, it's go.gl. Sorry about that. Ignore that link. Oh, I didn't add that it's autocorrect that's introducing a D in between. Yeah. go.gd/result validation. The second link is the actual result submission link. Go ahead and click that and choose. Don't have to do it. You can do it after the session as well. I'm not trying to distract here, but In case you're keen on doing that, this is the time. You select session number, you select the active season and your current code Vipassana season 15, and you select the session. Um, let me just- yeah, if you can see my screen right now, select code Vipassana season 15, select session number 2, which is Zero-ETL data federation. Scroll down, it will tell you exactly what you need to submit. It should be the first screenshot of step number 6 with your project name. So you can't just submit this. You have to open AlloyDB in your Google Cloud Console in your Gmail account. It should be showing your active project here, and you should submit whatever you're seeing along with the uh, this page, AlloyDB for PostgreSQL. This is what you should be submitting. Yeah, so that's that. Let's get going. Moving on to, we are still in Code Lab step number 4, by the way. 4 is completed. I showed to you how my AlloyDB cluster and instance just got created. You're not going to do any of these steps because you won't be able to create a AlloyDB cluster or instance without a building account. But just know that we have created the cluster and instance. Right here, as you can see, the service account, if I go to my overview, AlloyDB overview page, it showed my cluster and instance. I clicked my cluster and it is showing the service account. Why is the service account important? All of Google Cloud services come with an active service account once you enable that service. Once the service is initialized, it assigns a service account so that you can provision whatever permissions that service account needs to perform whatever you need that service to perform, right? So in this case, can someone guess what permissions does this AlloyDB service account will need? Take a wild guess, depending on what we have discussed. Read what? BigQuery. Perfect. That is the answer I was looking for. So if you go to step number 5 of the code lab, the permission says clearly that your AlloyDB service account will need BigQuery's data viewer and BigQuery user permission. So that, and BigQuery read session user permission, so that it is able to read through BigQuery data. So how do we do that? Go to IAM and admin. You don't have to do this. You can just watch me doing it because you don't have an AlloyDB cluster instance if you forgot. All right. So I'm here in the I'm copying the newly created cluster service account. All right. So I'm going to the IAM and admin page of my Google Cloud Console. And I'm waiting for it to load. There we go. I click grant access. I paste the service account that I just copied from AlloyDB. I hit enter. Now I go to assign roles. I go to the code lab and I copy whatever I need to assign. Data viewer. Let me go back here. Data viewer. There we go. Add another role. What is the second one? BigQuery user. I copy that. Come back here. I paste it here. BigQuery user. There we go. There was one other role, which is BigQuery read session user. I copy that, add, paste it here, and there we go. Now I save it. It will take a few seconds to replicate. To show up. All right, policy updated. It may take a few minutes for these changes to become active. I'm going to assume that it is already active. Permission setup is complete. Moving on to step number 6 of the code lab. So we have already created the cluster and instance. We have already provisioned the permissions that are required to read your data warehouse's data, which is BigQuery data from AlloyDB using SQL queries. Now it's time for setting up the extensions and get going with the federation. So how do we do that? Go to your cluster overview page. So go to AlloyDB. This is where we are. This is the cluster overview. Here I am. What am I doing then? Connect with your database. So I'm going to go to AlloyDB Studio. So click AlloyDB Studio. That's what the code lab says, right? Click AlloyDB Studio and connect with my details. These are the details that you provisioned when you set up AlloyDB cluster and instance using the second code lab. If you remember, I showed that to you a few minutes ago. So now I'm authenticated. I'm inside AlloyDB Studio. All right. So you're just listening in at this point. You're not trying hands-on anymore. Now it's time for you to watch, because you know that you can't create a AlloyDB instance without a billing account. So you can watch hands-free. What I'm going to do right now is I'm connected to my database. On the query editor tab, I'm going to enter these statements. I'll tell you what these statements are doing. So here I am. First thing, I'm creating an extension for BigQuery SDW. It's disabled. So it's saying clearly the database flag must be set to on to enable this extension. So how am I going to do this? I will go to all clusters, scroll down. I'll go to my cluster, select that, scroll down to my instance, edit primary. I'm editing my primary instance, scrolling down. I'm going to advanced configuration options, add a database flag, and here I'm going to type in SDW. So we need SDW.enable. It is for federated data something. Does it say what FDW is? Oh, I forgot what it means. It's Federation Data Wrapper. Federated Data Wrapper. Federation Data Wrapper. Yes, I remember. Something data wrapper. I'm assuming it's Federation Data Wrapper. So let me just enable this and done. And I'll add another database flag. Let's see, everything related to FDW is selected. Default execution mode. No, we don't know what. Downcasting on. Vector downcasting on. Done. And update instance. Connections will be temporarily impacted. Existing sessions will be terminated. That's fine. Confirm it. Because we are enabling the enabling this flag. This flag needs to be enabled before you can automatically turn that on from your query editor. So before enabling your extension, you need to turn the database flag on in order for your federation data wrapper to take effect. So that's what is going on at the moment. The instance is currently updating, so we cannot do anything. Let's just give it a minute. While I'm waiting for that to complete, show of hands, only if you got everything that we discussed, like understood, you realize why we need data federation. Perfect. How many of you were able to successfully submit your results? Yes, there will be certificate for submissions, result submissions. Since AlloyDB can query BigQuery through Lakehouse federation, how do we decide which data should stay federated in BigQuery and which data should be materialized and put on faster and perform? That is totally up to the application design. I would not duplicate data unless it's absolutely required. If essentially, if I'm using AlloyDB, I don't need to worry about speed. I will definitely not be not be storing anything unless it's absolutely necessary for some complex computing that you need to do on the data. However, Lakehouse Federation, that's what we're doing right now. Querying BigQuery data through AlloyDB is using Lakehouse Federation behind the scenes. That's what we're doing right now. How do we decide which data should stay with? Yeah, I hope I answered your question, Easton. You see, ideally, you would want to materialize it if there is a business need for it. You would want to materialize it if the relational database or the whole computer is taking so much time, it's inducing more latency. But that doesn't happen for AlloyDB. So you don't need to materialize it. But if your design demands it because your application needs some advanced or some other thing is dependent on the connection to AlloyDB, or you're going to change something in BigQuery that you need the data to be persisted somewhere with the current state, then yes, you would need materializing. I hope that helps. All right, now let's see if the thing is complete. It's still updating. Like, I can take a few more questions while it's updating. It'll take about like 30 seconds, 45 seconds more. Yeah, what is your question, Aparna? No, so Mapil and Meera, you don't have to take the screenshot of an existing cluster. You can take screenshot of your cluster overview page. In your case, it will show no cluster present. I'll show you, wait, I'll show you an ID of mine that does not have billing account. So I'll show you what you need to submit in that case. So I'm here. Um, this account does not have any billing account, as you can see. So this is what you need to submit. In this case, I don't have a billing account. I don't even have a cluster. This is just an overview of all the clusters you have. In which case you don't, in this case, you don't have a cluster. So just submit this. That's all. Remove this, the flag on top. You can dismiss this and just submit the remaining ones along with your project ID showing up. That's all. Yes, Amisha, you can do that. The network error that we saw in the app was because my session was not running for the AlloyDB quick setup app. That's why you saw that error. Okay, let me just quickly check. It's still updating. All right. Anyway, let's go to the code lab and see what are the next steps. So what I'm doing here is I'm enabling this data wrapper extension once your database flag is set. So once this extension is set up, I'll create a server because this server is what is going to enable that foreign data uh, communication. And the next one is mapping the user. So in our case, the username is Postgres. This is the username that this is a default username. If you change it later, edited your cluster and changed your user, that's fine. It's not this is a default user that comes with the um, user level login. So continue to use that. So I'm mapping this user to this server so that this enables that communication every time an application or a service account queries this database, AlloyDB for BigQuery data. So if it is not running, I have, yeah, it is still updating. Let's give it a few more seconds and come back here. But in the meantime, I already have another instance where this was set up. So I'm going to take you there and show this extension creation. All right. So create extension if not exists, BigQuery at review. This is executed successfully, which means the extension is now on. So now I'm going to create a server. This will fail for me because the server already exists. Yeah, I already ran this step. Now I'm going to map the user. The server creation will be successful if you're doing it for the first time. Or you can do, I don't know if create or replace works on this, but yeah, you can just change the name of your server. Yeah, there we go. Successful. And I'll map the same user to another server right now. There we go. It's successful too. Perfect. So now I've been able to successfully enable the extension and close this. So here we go. This is where we are. We have all the tables that we need in BigQuery and we have enabled the extension in AlloyDB. Now go back to the code lab. The next step is for us to connect the BigQuery table. So how do you do that? In your AlloyDB cluster, in your AlloyDB studio, if you expand your username, you will see all the public tables and you will also have another component called BigQuery FDW schema. So expand that. Okay, what is this? And BigQuery table. Okay, here we go. So expand your public schema. As you can see right here, since I already have some tables, that's why it's loaded. I really hope this update finishes in the next couple of minutes. Once, if you update an instance, it will take almost like half the time it takes, or at least like 3/4 the time it takes to set up your instance the first time. So you'll have to let it go through. However, this is what I was talking about. So you will see your public schema in AlloyDB, expand the default schema, and you should see BigQuery tables as an item. In my case, since I have some tables already loaded, you see this. listed here, but ideally when you're going back slave, this will be empty. You click the vertical ellipsis here and you view actions, you will see connect BigQuery table. So click that. You will see a connect BigQuery table dialog box popping up. Select your project ID, provide your data set name. Where exactly is your data located that you want to allow your database to talk to? So in our case, this is living in Froyo underscore data. And what exactly do you have? Which table exactly do you want to connect to? So if you want to create one, you can create one. If you want to create many, you can create as many as you want. Um, you can't, you have to name this and you also have to map. You can't do this in bulk through console. The reason is you have to physically validate and review the columns because there are some columns that are supported in BigQuery and not in AlloyDB only because BigQuery is um, uh, compatible with semi-structured data, unstructured data as well. So AlloyDB doesn't inherent like natively hold unstructured data while it supports semi-structured data. It does, which is it also supports embedding and everything. AlloyDB, like BigQuery, for instance, support graph data and other things. AlloyDB will throw error if you try to store the same column or the data type. So there are certain cases. In this case, it did not throw any such error. We have compatible data. So you just select that, provide a table name. Ideally, it's good to keep the same name so that your queries work. In my case, I already have the table here, so I'm renaming it. And then I click connect table. If you want to see it, just a second. Folks, can you go on mute? Whoever is speaking, can you go on mute? Yeah, thanks. Okay. All right. So if you want to see its equivalent SQL command, click new SQL command, and you should be able to see how to create this table at your end using SQL statement without doing it through this thing so that you can have this replicated and do this in one shot. All right. So you can copy it from here or you can just click connect table. So this will take a few seconds and your foreign server is connected. I'll just query it directly. And as you can see right here, you can query this data from AlloyDB without storing it in AlloyDB. It's federating directly from BigQuery. Repeat the same thing for all the 8 tables. In my case, I've already done that and it's ready to go. So I don't want to duplicate this. It's already there. As you can see consists of contains allergen, ingredient, products, recipes. All these things are there. Although I don't see allergen. Why is that? All right. Good then. I'll use the new allergen 1 table that I just created. All right. So what is the next step? This is testing the federation in AlloyDB. Remember the one important query. The reason I call it important is because something that we can remember from the allergen test. Let's copy this SQL statement. Come back here and paste this SQL statement here directly. Now, same query that we ran in BigQuery. The only difference is in BigQuery, you will have to prefix your table name with the dataset name. Here, you don't, there is no dataset concept. You're not storing the data in AlloyDB, right? You're directly calling this as a foreign table without having to store it in AlloyDB. So all you have to do is just run this query. We'll get, if the federation went through, you will get the result here. So this is the same query. It is just joining allergen table, ingredient table, product table, and everything. And it is checking if Midnight Swirl has any allergen or not. All right. I'm just going to rename the allergen table because if you remember, I changed the name of the table. Allergen 1. Am I using that here? Product ingredient. No, I'm not using the table. So it's okay. So I'll just run this query here. Now this is the federation in action. There we go. This result that you're seeing right here, that Midnight Swirl has allergen named soy through one of its ingredients, which is Midnight Base 204, is coming straight from BigQuery. You're just querying it in AlloyDB. So why AlloyDB? Like I said, all the advanced indexing and superfast searching, superfast writing, superfast transaction and analytics, everything that AlloyDB is capable of you can imagine, or you can write in this query and make sure it works on BigQuery data through AlloyDB. So that's exactly what we wanted to achieve in this session. And there we go. We have everything we needed. And to clean up, if you ended up creating the AlloyDB cluster as part of this session, go ahead and delete it probably after Monday's session, because we will need, if you are using your own billing account and created a cluster, save it only till Monday. If you don't want this until Monday, just delete the clusters already. Uh, I'll tell you a different approach to get this data and build that agent on Monday. All right. But most of you would not have created the cluster in instance, because as I informed, this season is all about you getting the design aspects of it, going through the concepts and understanding why exactly um, we are doing certain things, but getting to experience the data part of it, getting to experience certain elements of the lab while keeping the momentum of understanding agentic data cloud. So that's exactly your goal. So if you did not create cluster instance and did not get to experience the federation hands-on, that's okay. You can do it in your own projects for a different use case at your own time. But you now that you know that it's possible, try to implement it for your use cases. Now that we have our unified data layer, what we'll be building in part 3 is an agentic system that sits on top of this architecture, which read raw unstructured PDF data from uh, your bulk PDFs for your business, and used knowledge catalog to push the data to in a structured, intelligently related format in BigQuery, and you unified that data through your transactional layer, which is AlloyDB, and federated through AlloyDB without having to store it again and again. All right, so that's exactly what we have accomplished today. Next session, we build the agent. We take a few questions. We are uh, not at time. We do have 20 minutes. So if you have questions, we can take them. But first of all, let me just take a pause here and ask you all, were you able to follow through? Do you understand why we did what we did today? And can you tell me some use cases that you will leverage this probably, that you can think of why you would need this in the chat, please? Yeah, for folks who are repeatedly asking about result submission, definitely I'll show you because we do have time today. So like I said, go to the result validation app, which is the go.gle/result validation. This is the one. Choose the season, which is called Vipassana season 15. Choose today's session. It tells you the result submission step is in step number 6. So it means you have to go to step number 6. It tells you that it is in the first screenshot. This screenshot should be from AlloyDB for Postgres overview console, landing overview page with your Google Cloud project name visible in the screenshot near the top left corner of the console. As you can see in my screen right here, in my case, I do have the cluster, so it is showing something else. But in your case, you will not have the cluster. So your screenshot should look something like this. But on top of that, you will have your project ID showing right here, right above AlloyDB for PostgreSQL. So that should be your screenshot. And you submit that in JPEG format, which is mentioned here. You get 3 attempts to submit. And if you go to dashboard, you can see your overall score. All right, now let's take some questions. What do you mean site convenient? Site is active. Total. You mean, yeah. Any other question? Is there anything that I can answer? Yeah, the recording of the session will definitely be shared tomorrow. It will take some time to process if it's a lengthy recording. What are the use cases that you use this in? Use case. There we go. Yes, Kaushik, we did do the database flag enabling. Remember I showed to you how to do that. Go to, yeah, that part is probably missing in the code level. I'll add that before tomorrow. Later tonight, I'll just add that step. I know that it directly say, go ahead and go ahead and run this extension, but you do have to enable the flag. So go ahead and enable the flag, because in one of the instances, all the flags are enabled apparently. So I didn't realize that it's not enabled, but I will include that step. However, I showed that to you in the demo today. It will be there in the recording as well. So how would you enable the flag? Go to cluster, edit your cluster, edit your instance by scrolling. See, there you go. My edit instance is updated right now. It took about 10 minutes or so to update it. So edit your primary instance. When you're editing it, it will show your edit primary instance page. Scroll down, go to advanced configurations section, advanced configurations option section. You will see add a database flag section. Click that and choose a flag. Search for FDW and set that flag enabled on. Set enable vector downcasting also on. These two you need to submit. You need to set on in order for you to be able to complete this extension step. I hope that helps. Loading paper medical records to electronic health record application via BigQuery inference query to Great. Yeah, that's definitely a good use case. If your health records are related, knowledge catalog will really come in handy. Season 14, I missed that. I know that it's not listed. I just got busy. I was not able to give you the previous season's link in the site. I'll add it. When have you used AlloyDB AI as mentioned in step one? No, step one is an overview. That's a background of what all you can leverage. We haven't used AlloyDB AI. We have done a lot with AlloyDB AI in season 14. This time in this session today, that was not the focus. The focus was to show federation, Jason. If you're interested in doing AlloyDB AI, we have done a lot of sessions in the previous seasons. I'll share you the season 14's link. Yeah. Is it required to submit today? I mean, it's up to you. If you want to participate in the leaderboard thing, then yes, you have to submit all 5 sessions and you have to submit it real uh, fast so that you are in the top 50 or top 20 or top 15, whichever makes it to the leaderboard. But if it's just about certificate, it's enough to at least submit 1 or 2 results. But do submit as many as you can so that you know that you're in the game. Yeah, you can submit today as well. It's open till June 15th, so you can take your time to submit. BigQuery tables, you did copy paste all the commands, but were the commands successful, Sneha? That's something I look at. Make sure you're successfully executing those BigQuery table creation steps. Those are pretty straightforward. It's boilerplate. You should not have any error there. If your table is not showing there, just refresh your data set and see if it is showing. Like, you should be able to go to BigQuery, expand your project name, and you should be able to see the data set, expand the data set. All your tables should be listed there. Tables, views, whatnot. Everything that got created. In your case, it will all be tables based on the script. Recording you'll get in the morning. Log files and GCS buckets from BigQuery using external tables concept, and then make those schemas. Yes, you can. Why not? BigQuery is able to process anything, any media file also. You can also process images and videos as external tables in BigQuery. You have to store them in GCS buckets or in any other warehouse and then bring it to federate through BigQuery for sure. But then, yes, the external tables concept will work with BigQuery for any media data. Sudeep, I hope that helps. I'm actually planning to try that for yesterday's and today's recording because I want to create highlights and create an agent that's able to answer questions from videos. Previously, also it was possible, but it would have taken a lot more tokens and a lot more effort to do that. But now it's very simple with all of these things that are possible right now with BigQuery. AlloyDB with BigQuery so we can query and analyze application data directly from BigQuery without moving the data elsewhere. Reporting dashboards and ad hoc analysis on live data stored in AlloyDB. That's perfect, Shiv Shankar. You will see some of those things we will be implementing in this season in the next 3 sessions. In the upcoming session on Monday, you'll be building an agentic application. And following that, session 4 is just showing a quantitative way of evaluating your agent that we just built. And in the final session, you will be exactly doing everything that you mentioned in three different personas. So you'll be building agents and dashboards. So that will be really fun. Plans to provide a graphical interface or direct button-based functionality in the future. You can actually do that from console directly. I'm using CLI because it's easy for you to run the command. Remember I showed you can go to BigQuery, create data set from right here. Let's click this, create data set. You can point and click, push buttons and do the same thing that we did through CLI. Services paid or not in Google Cloud. You will know that, Sneha, because if you don't pay for it, if you don't have a billing account, it won't work. It's simple. You won't be able to do that. So if you have a billing account only, then you'll be able to do that. If you are using a trial billing account or if you have put in your credit card, you can always put a limit on the spend, say $10 or $5 or $2, so that whenever it exceeds, it will stop working. So you know that your money is not leaking anywhere. There are other ways to monitor it, but that is the shortcut, the easiest way to prevent unprecedented or unknown, unexpected leaks. In case you accidentally left some instance or something running and you forgot to shut it down, that's the way to do it. Sonia, it's actually your whatever you see when you log into AlloyDB console. That's what you need to submit. That's all. It should show your project ID, project name on the top. That's all. Pushkar, it depends on a lot of things. How your agent is using it, what is your agent capacity, your instance capacity, how much are you basing your instance up. So all of those things will come into play. We can't just give you a direct answer to how much an agent will cost approximately. It depends on how and what services you're using, where your agent is posted, how, and cost is not just the cost that you spend on the service, it's also cost that you spend in building it, even if you're self-hosting it. Everything that comes into account will cater to the actual cost. But if you are interested, you can actually put in a tentative configuration for your cluster and instance for AlloyDB, BigQuery, and everything that you want. And you can go to Google Cloud cost calculator and you can get an estimate. Real-time analytics by joining transactional Postgres with BigQuery browser. Awesome. When adding tables, point and click didn't work. Where, Duncan, can you tell me which part? Hyphen, moving the comment from the top of the code actually worked. Are you talking about this one? Test the sorry, this part? Okay, got it. Understood. Okay. Can you put in the chat, Duncan, which step in the code lab so that others were trying that way? Rishi, what you need to submit as result is mentioned in the result submission app. So just go to the app, select the season and session. You will see what you need to submit. We have 3 more sessions, Mapilin. Step 6, line 7. Interesting. Okay, if the point and click method doesn't work for some folks for connecting the query table, please go ahead and use the query approach here. I hope I'm referring to the right one. Line 6 and 7. Okay. Sounds good. But if you go to the point and click approach right here, if I just go to this one, I click connect BigQuery table. Mm, I choose my dataset name and you choose your table. It should be pretty straightforward. I'm surprised your point and click didn't work. Can you tell me more about the Duncan? Like what if you can unmute and speak because it's I know it might be difficult for explaining that long answer. If you like. Yeah, Duncan, are you saying something? Duncan, if you're saying something, we're not able to hear you. That's fine. If you're comfortable typing in the chat, that's fine too. No pressure. Sorry for putting you on the spot. Um, I think so. No problem. All right. So basically, if the point and click in step number 6, if you're trying to build your cluster and instance, and if you're not able to do this point and click approach for some reason, feel free to remember how the query is also mentioned here. So just copy this query and replace the table name, and this should work. Replace the table name should work. Sorry, project ID and table name, it should work. By the way, both options should work. Okay, there we go. Command. Okay, this is the one that is generated while you're here. It will generate that with a double hyphen. I agree. Got it. But you know what? You can just directly, once I click connect, and I provide the data set name, Froyo underscore data, and I choose my table, say orders, for instance, not orders, something else. Let's say Froyo data materialized. I'll select all the columns and I'll just say a destination name, maybe materialized orders. Data materialized. All right. And then I can directly click connect table. If this for some reason Pushanopi doesn't work, copy the view SQL command, just copy this part, the create foreign. This is just the comment part, leave it out. You can just run this one. Edit in Studio, you should be able to get that. I would prefer just clicking connect table here and get the sync going without having to copy paste the command or whatsoever. Oh, query, I mean. So if you see, I'm able to query this newly connected table directly from AlloyDB. As you can see, this is an external table, which remember in previous session, we saw that there is an object table created with literally uh, paths and metadata information, which you can't really use to make sense of your actual application. So that's the reason we went to knowledge catalog. And knowledge catalog literally extracted the files from these locations, use these metadata information to make the files talk to each other and get the result stored in structured table format, which you then used here in this final query, which got us the data that we need. All right, so that's pretty much it. And we are okay, systematically fails something. Got it. Got it. I hope you're able to run the command and ultimately get the command, the create table statement working, the foreign table statement working, Duncan. Just let me know if you're able to create the foreign table. That should be good. Okay, Kaushik, it'll take like 7 to 8 minutes for your instance to be completely updated. So we are going to be at times really soon in 4 minutes. So thank you so much everyone for staying till the end of session 2 as well. We have 3 more sessions coming up. Like I said, we'll use the dark data that we have completely transformed into structured information that is meaningful and federated through a transactional database. Now we'll use that to build an agent, and we'll also be using MCP Toolbox. We'll be talking about what's new in MCP Toolbox and what all you can do to leverage that in your real-time, real-world multi-model applications. And finally, we'll be evaluating that agent and building out the downstream applications, which are business intelligence and chat agents for your application. So that's what we're going to do in the next 3 sessions. I hope to see you all Monday. Thank you so much. Thank you, Duncan, for confirming that it works for you. And thanks everyone who tried even without billing account and tried to submit the results and stayed this long. Thank you so much. Bye and see you all Monday.